So during this review session, if there are any questions you would like to see worked, feel free to just drop that in the chat and we will answer your questions. All right, so we will go through this page by page, and if you see something you'd like worked, just drop it in the chat or feel free to speak it out.
Right, so to begin, we're gonna be going over chapter 3, 4, and 6. Now, chapter 3 is over quadratic, piecewise, power functions. Now, if there's anything on this page that you want to be reviewed, just go ahead and say so, and we'll review it for you. Now, are there any questions on this page? Okay. So remember, you should be able to say something in chat or speak up. Did you want? I'm not seeing anything to chat so far, so I'm going to scroll down. Now, are there any questions on this page? So, and also we're going to drop off the packet in the chat real quick if you want to follow along with that. Okay. Any questions on this page? Don't be afraid to ask for help for any stuff you see on screen. Any questions on this page? Yes. Okay. Which question? Oh, okay. Sorry, I can't. I have to like turn my head to check chat.
Oh, I'll tell you when there's something in the chat.
Okay. Okay. Scroll down. Quadratic equations, right, parabolas. Any questions on this one? Questions on this one? All right. Any questions on this one? All right then. Any questions on this page? All right. Any questions on this page? And if I'm going too fast, just let me know. Gonna go to the next page. Any questions here? All right. There we go. Okay. That's all out quadratics. Any questions on this page? We'll move on to the next page. Questions here? All right. Any questions here? All right. Any questions on this page? All right.
Hello.
Questions on this page?
Yeah. What if I got some water first? What if I got some water?
Oh, go for it.
Next one.
We're on page 50.
looking at this page, do you like have any questions, or would you like us to go back for something? We haven't had any questions so far asked.
Got the calculator tricks to. This is stuff that would probably be allowed with a calculator on a test.
That's my guess.
Yeah. I'm assuming that for your tests, a calculator should be allowed, or at least for only certain portions,
Second half.
maybe something like that. I'm not really sure of the structure.
Oh, it should be good for now. I'll let you know.
Right.
Table graphs.
Go to this page here. Any questions on this page?
C7. Done.
And number 7. I don't think we go. So what is the graphic motion? Now, when it comes to graphing piecewise functions, typically calculator don't make that easy. So I'm going to graph this by hand. That's close enough. Okay, so this function here, this piecewise function is saying from 0 to 2, it will be 5. From 2 to 4, it will be 10. From 4 to 6, it will be 15. And from 6 to 8, it will be 20. Now, pay attention to these inequality signs here, because it'll show whether you put a dot or a circle in certain spots, and you'll see what I mean. Now, let's start off with 5. We'll say this is 10. Okay. Now, if we're at 5, from 0 to 2, not including 2, but including 0, it will be 5. So I'm going to color in where the 5 is. I'm going to go to 2. I'm going to put a circle there. Right. Now for 10, color it in right where this missing spot is. And go over to oops, and go over to 4. Put a circle because we're not including 4 there. And now for 15, we start at 4. We start on 4 and end like before 6, or we don't land on 6, so to speak.
Empty dot.
Not on 6. Good way of putting it. And finally, for 20, it will look like this. And that's what our piecewise function will look like when we graph it. And it says what type of function is this. I already told you it's a piecewise function. It's where it's broken up into pieces. That's how that help you remember it. All right. Any other questions on this page?
Don't write, save it.
Makes sense again when you go over it. Thanks. And 13 is just, I feel like I could imagine it pretty good. If it's going to be absolute value of X, it's just going to
A V shape, yeah.
be.
Next page. Any questions on this one?
You put absolute value on the 84 here.
I'm going to build this map. See what map is. scroll down. The number, this ABS, that's short for absolute value. So and it shows the bars by default, but some calculators only have ABS. So ABS of -1 would be 1 because that's the absolute value of -1. Right, that answers your question.
Yeah.
The calculator is formatted a little differently, so I could see it just a half column on the GI. That's just how. Other questions?
So 1 through 5 at the bottom. I want another calculator. Be sure you can just put all those in and we'll try to generate a parabola.
Yes, you can use a one ray, one quadratic regression. Let's see. Trying to think of a way of. So what you, the way you find would be a way of the quadratic function.
I could actually answer that using the formula, generic formula for a quadratic function. However, go down to the next page, you'll say equation of quadratic function. That's all the information you need.
Yeah, this is what I was thinking, built-in system equations.
That's the only way I know how to do it.
But the quadratic function, if you know what that is, unless you're showing, you just by hand, that's a very. So do you want me to show you how to do it on a calculator? Or do you want me to do it by hand?
Yes, please. Calculator.
I'll do calculator, it's easier. Okay, so first we need to set in our data points. Now I'm going to do number 1 here. I am having trouble drawing today. There you go. Now I'm going to go to the stat button. You know what that is? I'm going to go press enter on edit. And for L1, which will be our X values, I will put in 0, 3, and -2. Okay. Now for my L2, it will be 1, 10, and 15. Okay. So notice the coordinates 0, 1, 3, 10, -2, 15. Now I'm going to go to stat again. I'm going to go with the right arrow to count. And I'm going to go down to quadratic, which is short for quadratic. I press enter. My X list is my L1, my Y list is my L2. I just press enter, and there you go. It tells you everything. So for number 1, that quadratic should look like 2x squared plus, rather, minus 3x plus 1. Y equals, by the way.
to our online participants. That's, whatever questions you have now.
Guess they thought they got those. I'm sorry. Did you want me, so you asked that I show up my hand?
Yeah, so I got the quad rag. I want to see the graphic. I thought I just did graph.
Or you
You should
want
see
me?
the parabola.
So what are you trying to do?
So for number 1 on 3.5, this graph is a parabola containing the certain points. If I want to just be able to see that parabola, I won't be able to get other points on.
You can't really find the parabola just by plotting the points. What we did was a function called quadratic. You've done it. It's where you draw a line. This is a quadratic that's been drawn. Okay. And if you look over here, can't really draw on the TI-84, but if you look here, it says y equals ax squared plus bx plus c. It says a is 2, b is -3, and c is 1. That's why I said 2x squared minus 3x plus 1. Over here is the final answer.
I can put that.
But I can do it by hand if you want me to.
Do I need to know it, or should I just?
I can't say for sure. For sure. Have you ever had to do that before?
By hand?
So I would guess that not.
Okay. Even when I've got extra time.
Hang on this page. Any questions on this page?
Let's see. Pretty sharp.
For number 11, it's basically the same we did before, except with more data points. Though the quadratic model should, or the quadratic equation should not exactly equal the data points this time around. But they'll fit the best possible quadratic.
So I was kind of being stuck on some homework too, that you get those points and they don't all line up to make an exact line, but they want you to find the best possible line to.
Yeah, so it's quadratic function we used earlier. It's this one.
Okay.
Just make sure you know what you're telling it's X list and what you're telling it's Y list. Okay. So stat edit goes to your list, right? And going to stat to the right where it says count, quad reg, or alternatively lim reg, cubic reg, quart reg,
Yeah.
ln reg, power x reg, power reg, you know, all the regs, right?
It might be, yeah. Trouble I'm asking for Linda. I suppose it makes sense.
So I'll just use a last stage. It's the same process. Like there's a line, not a good fit, but it's a line, right? Any other questions on this page, Rob?
Define the power function.
Want me to do 21?
Sure.
Sure, okay. Well, it started, I'm gonna clear my L1. Let me try. I want to clear my L1. I want to clear my L2. Okay. Now L1 is my X, L2 is my Y. 2, 3, 4, 5, 6. 7 and 8. 3, 4.5, 5.8, 7, 8, 9, 10, 10.5. Now, if it's asking for a power function, we're going to go to stat. I'll scroll down. Power reg, WR reg. All right. Now we're going to click on that, select it, calculator. X is my L1, Y is my L2s. I just press enter. And it's over.
What is the definition of the power reg? That is the closest line possible? Oh, sorry.
Power reg is just it's just an algorithm that constructs a line for you, whether it be a straight line, a whatever equation. It constructs an equation using data points. That's what reg does. Okay.
Supposed to
You don't need to know how reg works, you just need to know how to use it. Go on to the next page. Questions on this page?
I feel like we could just go through them and fill in the blanks with.
Want me to go through 1 through 6?
Yeah.
I don't know why 1, 2, 5, 6, and 3, 4 goes like that, but I'll do 1 through 6. So identify the domain range of a different type of function. Domain of the reciprocal function is of the reciprocal function. I know what the reciprocal function is like.
Twice.
Goes over it. Now, keep in mind, domain is the interval of x values. How I would describe it is the interval of x values that you're able to use. And the range is the interval of y values that you're able to get. Okay. So we are asked to show that in interval notation. Okay. Now, what x values can you not use? Actually, I don't think it asked for interval notation. Whatever. So for y equals 1 over x, what is an x value that we cannot use? Use 0. So I would say it's acceptable to say the domain is x not 0. Okay. Now for our range, what is a y value that we cannot get? This one's a little trickier to see.
not sure.
So we cannot have y be 0. That doesn't make any sense.
If X can't be.
Like, it gets close to 0, but it never reaches 0. Like, you can have x equals 10 billion, y will still not be 0. You can't divide by 0 to make y 0, so you just can't have y be 0. It's supposed to be, there you go.
Makes sense.
So for the domain of the constant function, let me erase it. Or I tried not to erase all of it.
Highlighter. Okay. The domain of the constant function g of x equal to k, where k is like a constant, which is a number like 7, 10 or something or another. It's a quantity that does not change. Or so what's the interval of x values that you can use? When I say use, what are the ones that don't make the function explode?
Well, I think 0, then K needs to be 0, but G can be anything. Not sure, what do you mean by explode?
So, well, they usually say blow up or something, but we can't plug in 0 for the first one because that makes it undefined. So that's what I instead I said explode. So really, to answer number 2, you can use any x values. There's no x value that will leave this undefined at any point. And I think you said that the range is equal to k, which is true because you can only have k as your range. So I'll just put in this little space there, all, and I'll say k right there, okay? Does that make sense?
Yep.
Okay. Now the range of the squaring function, I'm assuming it means y equals x squared.
Are there any x values we cannot use?
That you can't use. Use negative number, you can still get. Imaginary count.
No, this is in terms of real numbers.
0 makes sense here. Not sure, are there any x values you can't use?
Hope you can use it, you can use all real numbers. Now, what's your range? What is the interval of y values that are present?
It's gotta be positive.
Positive and 0. 0 is technically never like either negative or nor positive. But yeah, it's for 0. If I want to write that in interval notation, it'd be from 0 to positive infinity for your range. And for your domain, if you want to put that in interval notation, it's negative infinity to positive infinity. I'm writing very big here. Does that make sense?
Yep.
Okay. Anything else on this page?
I did say I would go over 3 and 4.
Yeah, probably should.
So I'm gonna graph the reciprocal function real quick to show you. 1 over x, graphs it really quickly. So notice that on the interval for the x, on the x-axis, which is the horizontal line, halfway through it at 0, which is the origin, going from 0 to the right, is that function increasing or decreasing?
Decreasing.
Yeah, because you're going down, this x gets larger and larger. Now for the left of the origin, is it increasing or decreasing?
Increasing.
Actually, never mind, hang on, sorry. Let me start over. Okay, from left to right here, on the left of the origin, is that increasing or decreasing?
Left to right is decreasing.
Yeah, okay. Now from the origin to the right, is that increasing or decreasing?
Decreasing.
Right, so it's decreasing on from negative infinity to positive infinity. Okay. Sorry, I didn't mean to confuse you earlier.
What about from x equals -1 to positive?
-0.1.
Just to the left of the graph, and then just to the right of that, it would be increasing.
No, we should be decreasing on the entire interval here. Because over here, you're going down over time. And keep in mind, the larger the y value, the larger the negative value, the less down the number line you're going. So like negative, what was that, like negative 17.75 is far less than negative 0.3. Okay, remember the number line. And to the right, we're just decreasing the y value as we go. Okay.
It's a tad confusing. There's definitely an increasing value at least some moment from going left to right.
So remember what I said about the domain. We can't have x equals 0.
Oh, okay.
Like x equals 0 does not exist for 1 over x. So we just start from here, we go over here, and we just jump to this side. That's all we're doing. We never actually touched that line. So no, there was technically no way we are increasing from left to right. It's only decreasing.
All right.
Does that make sense?
I think so.
All right. If we looked at the absolute value function, which is the absolute value of x. It looks like that shape.
Yep.
Excuse me. Can you tell me where it's increasing and decreasing?
0. Start. Where 0 is.
Let's ignore x equals 0. So from x less than 0, is it increasing or decreasing?
Decreasing.
Yes. For x greater than 0, is it increasing?
Increasing.
Yes. As x goes up, y goes up. As x goes down, y goes down. Right?
Never have any negative value.
Yeah. Which even if you had like a straight line, it would only be increasing anyway. Actually, take back what I said. As x goes down, y goes up anyway. So it's decreasing there and then it's increasing on the right. I feel like I might be confusing you there because I feel like I'm confusing myself almost.
So you're trying to figure out.
It's just showing where it's increasing or decreasing. Oh, one more thing. if you want to answer that question, say like on increasing for the absolute value function, put in domain or interval notation. So for increasing, I would say 0 to positive. I wouldn't include 0 because of math technicalities, I'll say. So just say greater than 0 in that case.
So you're trying to look at the function and see if it's.
Yeah, and you tell where it's increasing and decreasing.
Oh.
So this is the interval where it's increasing from 0 to infinity, which is like anything to the right. Okay, any other questions on this page?
Let me make sure I can get 15.
Okay. Can you tell me what type of equation that is? What kind of function it is? That's where I always get my words mixed up.
One foot roots.
If you want to put roots, I think you need to go to, I'll help you graph it. Go to map, go to map. Right here where it says in square root, it might say x square root. Press enter, and it'll give you an option to put in the root. I'm going to put in 6 for 6th root. Also to the 8, it needs to be multiplied by 8. So let me go to the right, there you go. Put the inside x. And let me know when you got that.
Yeah, just cutting some down. Should look like that.
All right. I'm going to move on to the next page, if that's okay.
Yeah.
Let me know if you have any concerns on this page. No, that's on Zoom. We go on the next page.
Oh, I'm sorry. 18 on the last page. Is that one not a function?
Correct. And I mean, these are referring to y as a function of x.
Yeah.
So the reason that's not a function is that each x value is supposed to give you only a certain y value. You can't have one x value say 2 different y values because that doesn't make any sense.
I always do the vertical line. It hits at the same point.
Yeah.
It's not.
That makes 17 also not a function either. 21 is a function if you pay attention there, and so is 22.
17 and 18 are not. 21, 22 are.
Yes. Additional equations and inequalities, just let me know. Concerns on this page.
Okay, C12. Oh, thanks, sorry, still on. C12 done. Good.
Solve equations with rational powers. So we have x minus quantity x minus 5 to the 1/2 is 64. I want to express this in radicals for this equation. So any idea what we should do first? What should we get rid of first?
64.
So we want to get x by itself, right? What do we need to get rid of first? I want to get rid of this 1/2 here. I'll get rid of that exponent. So note that if you have something to the 1/2 power, it's the same as the square root of that number. Okay. But what I can do is I can still square both sides. And if you remember properties of exponents, if you have something to the power and that quantity to the power, you can just multiply these exponents here. So this 2 and 1/2 cancel.
That the 1/2 is 3/2.
3/2 is. So I'll put it to the 2/3 power on both sides. Okay. Because I want to multiply by its reciprocal to make it 1. Okay. So those canceled. So now we're left with x minus 5 is equal to 64 to the 2/3 power. Finally, what should I do to get x by itself?
Yeah.
5 to
Yeah.
64, 2/3.
Huh?
69 and 2/3.
Don't worry about simplifying 64 to the 2/3 yet. Okay.
To get x by itself.
We just want to add 5.
Um,
So x will equal 64 to the 2/3 plus 5. I think it wants it sort of in that form. And
So if I put x equals 69 and 2/3, it would wrong.
Because you can't combine those, yeah. Because they're not like-
not all our terms.
Good to know.
So you have to do 64 to the 2/3 to get like a number and then add those together and then you. But as it is right now, you can't add the 5 to 64 because they're not. Like,
Now 64 to the 2/3 does simplify to 60. Okay. And that's equal to 21.
Right. Gotcha. 21. Okay, thank you.
Hang on, let's do it here. Okay. Any questions here?
So,
What was that?
I think I'm good.
questions here?
They wanted me to show the work for algebraic and graphical methods. Let's see, can I just get an example for 38?
Let's do the graphical method first, since they brought it up. So basically, for this part, you're just gonna graph that part. So we're gonna have x plus 5. I'm gonna put that to the fourth. First graph. It's kind of hard to see here. If you keep going to where it says greater than 16, it's hard to see. It seems like it might be something maybe like negative. No, I mean, the X doesn't have to be, that's just how the function looks. So let me do it algebraically. Oh, here we go. So if I go to the table where it has all bunch of X, Y coordinates, like for X, if we want it to be greater than 16, it's for X less than -7 and X greater than -3. You'll see what I mean here. Let me do it. So if I want to get X by itself, you can treat inequalities like equalities with some given exceptions. So how do I get rid of this fourth power of 4?
How would you get rid of, to the second?
Square the other side, right?
Right, so how would you get rid of to the fourth? Square the second,
Square root of the second.
so then you can fourth root.
This. Write it like this, with 1/4 on both sides. I'll do it the classic radical way. That's the fourth root, okay, on both sides. Can you tell me what fourth root of 16 is? Yeah, so it's just 16. Or I guess we want to get technical. Fourth root of 16 is 2. You could think of it as squaring it once and then squaring it again of the fourth root. Square rooting it once and square rooting it again. So like square root of 16 is 4, and then the square root of 4 is 2. So here we have x plus 5 is strictly greater than 2. How do I get x by itself now?
Subtract 5 from 2.
So greater than -3. Oh, I forgot something. When we took the fourth root of both sides, we need to add a plus or minus 2 over here. So one of them is -3. What would the other value of x be?
7.
Right. And we flip the signs when we do -7. You see why?
because X is greater than -3, but less than -7, so
It's because we flipped the signs on the second solution. We need to show that.
I have to disagree with that. You leave the sign the same and the fact that you're taking positive and negative fruits,
Yeah,
but not multiplying by a negative. You multiply or divide by a negative. With the sign.
if you look at the table. X equals -7. And less than that is greater than 16, because we want this. greater than 16. That's why I said inequality as well.
Okay.
So is that too confusing?
I think I got it.
I think you got it.
I can look at the tables and double check and make sure that it's signed.
You do 36.
Greater than or equals, like, if that were on the other one, I know X is less than or equal to the -7.
Move on to the next page, yeah.
Check. I think I get it. Look at the 59.
So the wind chill temperature when Fahrenheit is given by y equals 0.0052x squared minus 0.62x plus 15, where x is the wind speed in miles per hour, where the wind speed between 0 and 90 miles per hour is the wind chill temperature -3 or below. Or wind speed. 3 degrees Fahrenheit or below. So
So temperature is constantly 20 degrees Fahrenheit. But chill makes it seem like it's negative.
y measures your wind chill and x measures your wind speed. The constant outside temperature is just an environmental factor. So
By what our equation looks like.
if you want to see when it is -3 degrees Fahrenheit or below, you're going to want to construct your function like this. 0.0052 x squared minus 0.62x plus 15.0 will be less than -3, less than or equal to -3. Do you see that?
Yeah, if I'm trying to. That is the graph. Look at the greater than or. Or sorry, less than or equal to.
Less than or equal to.
I'm gonna find that one, is that in math?
What are you trying to do?
Use that symbol in the graphing equation. Less than or equal.
You can't really. I don't think you can really graph inequality, you're going to graph the function. So I would just graph the function like y equals. Right, so if we wanted to graph this function real quick, just to take a look at it. To the window. X will go from 0 to 90.
Five, 10, 10, 10.
I would leave it alone. So going by the scale, we want to see when our function is less than -3, which is somewhere between here and somewhere in between here. See where that is,
Yeah,
right? Now, if you want to do this algebraically, you can use stuff like the quadratic formula to find it. Where if you added 3 on both sides over here, you'd have that less than or equal to 0, right? You find the quadratic or the zeros of that function, and then you see at what points is that function when added 3 is less than 0. Okay. So let me take a look at the table, see if that tells us much. It's not going to give you an exact answer, but we should expect our answer to be something close to 50 to somewhere between 69 and 70.
all right. What would be the answer there?
They want to know what wind speeds would give you a wind chill temperature at -3 degrees Fahrenheit or below, right? Y is your Fahrenheit, and we're looking for the X values, our wind speed that will give us -3 or below.
So that would be,
So it should be from 50 to some number between 69 and 70.
looks like 69.
It won't be exactly 69. It's going to be a number between 69 and 70.
So they're going, I'm thinking they're going for whole values on the temperature. For the fractional values. So
Probably
just
an
round.
approximate answer of something like that. Do you want me to go it full step by step?
Unless they really need me to.
They might need you to, but I can't. So I'll do this one by hand, okay? So before I said add 3, so we're gonna have 0.005 2x squared minus 0.62x plus 18.0 will be less than or equal to 0, right? Now this is a quadratic equation. I can use a quadratic formula. 62 plus or minus square root of 0.002 squared minus 4 times 0.0052. It's actually wrong. It's supposed to be negative 0.62 in there. It's 18 over 2.0052. Okay. I'm just gonna look for what the X values are there. I'll calculate the smaller one. So it should look like this. Right. Let's see. Okay, 2 times 0.0052. That's 50, okay, I'm gonna switch this, I'm gonna go up here. I'm gonna switch that to a plus sign. There it is, there's the number between 69 and 70 I was talking about. All right. You probably might not have to do that up maybe for a final exam. But I figured I'd do it by hand. Okay, I'll go on this one.
Thank you.
Okay. Any questions on this one? Between pages.
So you could get 18, for example, 25.
Sure, multiply and divide rational expressions. Okay, so you're multiplying with 18 there. It looks like you're multiplying a fraction, right? How do you multiply fractions?
Sorry, I won't make it hard.
By each part, do you mean the top and bottom?
Yeah.
Yeah, you multiply numerator with numerator, denominator with denominator. It's like charging a battery, right? So so you multiply the quantity x minus 3 and the quantity x cubed. So that will look like this. That looks good. Now, if you're when multiplying with the numerator, you're going to FOIL, right? First, outer, and last. So you can rewrite that part like this. So x times x squared is x cubed. X times negative 4x is negative 4x squared. Negative 3 times x squared is negative 3x squared or minus 3x squared. Finally, minus 3, negative 3 times negative 4x will equal positive 12x. Okay. At the denominator, x cubed times x squared is x to the 5th. X cubed times negative 7x will be minus 7x to the 4th. And x cubed times 12 will be positive x, 12x cubed. And we're almost done. We need to multiply and divide rational expressions. So notice that negative 4x squared and then negative 3x squared in the numerator have like terms. So you can combine them to make negative 7x squared. Now, this expression and the numerator and denominator share a common factor. You know what that common factor is, the greatest common factor?
What is it?
X.
Oh,
Okay. So you notice that our lowest power, they're all being multiplied by our lowest power at 12. So we can express this as x times x squared, because we take away a power, minus 7x plus 12 over, now in the bottom here, its greatest common factor is x cubed, but we can only divide out x to the first power. So I'm going to write this as x times x to the 7th minus 7x cubed plus 12x squared. Okay. Does that make sense?
I think so. I can, this is gonna be recorded.
Should be recording. Yes, recording.
Where can I find it? I'll go back and see what I missed.
Oh, I mean, we can go back to that anytime if you want. You're the only one here. X's cancel out, so you're just left with that part, and that should be your final answer for number 18. Any questions on this for any previous pages? Huh?
It'll be on the STEM Center website. That's what they're.
I got some from my. Yep. I think I got it.
Any other question? We'll just take. Oh, okay. Questions here? Where we go with complex numbers? You remember what I is?
It's imaginary number.
Huh?
It's an imaginary number.
Well, we define I as the square root of -1. That's just what the number I is, okay? So if we take the square root of -4, that's the same as square root of -1 times 4 equal to square root of -1 times square root of 4, and that's simply 2i. Or you could just think of it as if you have a negative radical on an I. Okay, I just wanted to emphasize that because that's important. That's why I squared, if you remember, is equal to -1, because you're squaring out the square root.
Same with I cubed.
With I cubed, if you have I cubed, that's the square root of -1 times square root of -1 times the square root of -1. So that's actually negative square root of -1. Okay. We can show that. Sorry, that's tighter. There you go. Now I to the 4th is where you have square root of -1 4 times multiplied by itself. So that's the same as I squared, right? So that's just +1. Okay. And now the neat thing about this uncomplex number is that if you have I to the fifth, you get -1 again. Or you get square root of -1 again. And then if you have I to the sixth, you have -1 again. And it keeps going round and round. Okay. So are there any like problems on here you want me to go over?
Right there.
You're all right there.
So,
So the cubic and quartic functions. Typically equations where you have x to the third or x to the fourth respectively. Any questions on this page?
was there a good rule of thumb for just approximating windows? Just trying to think, you could look at the function and before you graph it, think of it.
So are you just asking how to adjust windows on a calculator?
I got it.
I mean, if we go back to the last function I did on the calculator, I chose the windows for x from 0 to 90 because it said for wind speed 0 to 90. So really, it's just hints from the problem, okay? Context. Context is important. So, oh, you also notice that for number 3, it specifically says it goes from x to y, so this is x from -5 to 5, and this is y from -5 to 5. This is x from -3 to 3. This is y from -12 to 10. Okay, that's how you set your windows. So x minimum would be -5, x maximum would be 5. Y minimum would be -5, y maximum would be 5. Okay. So the next one. Coefficient intercepts the graph of higher degree polynomial functions.
Could I degree defined again? Define degree again.
It's really the highest power of your polynomial. So if you had x to the 5th is your highest power, your degree would be 5. Right? How do we define degree again? Is it how many answers you have or the highest power? So for quadratic, its degree would be 2. For a cubic, its degree would be 3. For a quartic, 5, and so on, right? Any questions here?
Those make a decent amount of sense to me.
Just an easy way of remembering that. Look at the exponent, see which is your highest number, that's your degree. Here. No. Keep in mind, you might have to choose these without a calculator. Obviously, you can use a calculator to find which one's which. But if you're okay with them, there you go.
plug in each value for R that they give on the table there.
Also ask you to graph it from like 0 to 2/4. That you just let your substitute R. Modeling cubic and quartic functions. That's reg again. Okay, so again, for the stat, and where it says calc here, you have your quad reg, cubic reg, and your quart reg. Quart means quartic, cube means cubic, or cubic means cubic. Okay, makes sense. So same process as before, you just need to know which of these functions you're using here on your calculator. I'm assuming you know, right?
Give me 1 second.
Stop there for now.
All right, sorry.
No, you're fine. Well, again, those two boxes are really just modeling data using that equation. 4.6.3, the solution. to modeling equations. So how do you feel about those? Or how do you feel about this page here?
So examples of polynomial equations, it's looks like you can make 3 different answers.
1 and 3.
Yeah,
I don't know where 2 and 4 went, but for 1 and 3, yeah. So you set each of those quantities that are multiplied with each other to 0, and then you solve for x for each one. So for that first term, 2x minus 3, that's 2x minus 3 equal to 0. So x should be 3/2. For the second one, x should be -1, and for the third one, x should equal +6. Sense?
sorry. 3/2.
Yes.
Yeah. I think I get it. Yep.
Here it catches your eye.
So it's asking on 25 to solve f of x equals 0. That's just any of the intersecting points right there. So it'd be 25 on would be -3, 1, and 4.
That's to solve f of x equals 0. So yes, you set the equation equal to 0, and then you just
So
So see what x value y equals 0, right? Or f of x equals 0. Which would literally just be 1 and 4, just by looking at it, because it graphs for you.
Yep.
It tells you where those x-intercepts are.
what about the factorization of x?
Yeah, now that may require long division or synthetic division. I'm personally a fan of synthetic division, so do you want me to do that?
Sure.
Okay. Now, if we're doing synthetic division, we want to start off with a 0 that we know works, and thankfully it just gives us all the zeros or x-intercept of that function. So I'm going to start it like this. This is part B. Right. One of our zeros that we can use is +1. And we have coefficients 1, -2, -11, and 12. Okay. Now, what I do is that with this first number here, I bring straight down. And then I multiply this with our 0, which is +1. So 1 times 1 is 1. You with me so far? Okay, and now I add these two things together. And I get -1, right? Because -2 + 1 is -1. -1 times 1 is -1. So we take that product and put it over here. Now we have -11 plus -1. What does that equal to? And now -12 times 1 is -12. So we have -12. 12 minus 12, or 12 plus -12 is 0. And that happens, okay? So now that I have these numbers, I can express the equation like this. We have x minus 1, which is one of our zeros, times, we go down a power, and we say our coefficient of our x squared will be 1. I just write as x squared. Coefficient of our x will be -1, so I write as minus x, and our coefficient of our constant will be -12. Or our constant will be -12. Boom. Okay, this is why I like synthetic division. It's way less messier than long division. And now 2 ways you can approach this. You can use synthetic division again to break up the quadratic. The quadratics are typically much easier to factor with. So let's focus on this quadratic part here, because we can't reduce the x minus 1 any further. So what multiplies to give you -12 but adds to give you -1?
Start with whatever factors are.
We'll say -12.
Sorry.
4 and 3. But what about -4 and +3?
-3, +4.
So -4 +3 add to give you -1. -4 times 3 is -12. So that's the one we want. Okay, so we write it like this. We're going to have a -4, so we say x plus 4. It's just x minus 4. Never mind. Minus 4 times x plus 3. And voila, see that our zeros are -3, 1, and 4. We have x equals -3, x equals +4, and x equals +1. Right? And halfway through doing this, I sort of realized you could have just taken the zeros and expressed this as a factorization just with the zeros.
Suppose that makes sense. then that could be kind of like a rule of thumb, because if you've got the zero in the equation. it should always-
Yeah, assuming that it's irreducible like that. Okay. Any other questions here?
So I feel like that was insight.
It's the same kind of problem. Well, maybe you did have to synthetic division for that. It's just not gonna factor out nicely. For 29, that's kind of a different case because you can't just say y times quantity, 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 because it's being multiplied by a coefficient, if you know what I mean. It's being stretched or shrunk by a factor. That's really something we can keep in mind for that. So for that, I would definitely use synthetic division like I showed. Any other questions on this page? On to the last page, finding the maximum volume. Oh, this is just its own question. So it's not something it's not something you have to specifically memorize.
That one's on page 35. Volume of box.
What was that?
Wait, is 39 the example problem? Page 36.
No, that's a different problem.
You look at the first couple pages of the packet.
Yeah, by all means. Do that.
Can I get the page 2?
So it's asking that you evaluate expression containing radicals and simplify the expression containing radicals. So for number 28, was it? We have cube root of negative 128 times e to the 4th e to the 5th times c to the 6th. So what do you think we can do first? Since this is a odd root,
we can just factor out the, negative sign. Just make that positive, put the negative on the side. Now, we can also express it like this. We have negative cube root of 128 times cube root of 8 to the 4th times cube root of c to the 6th. There you go. Right, so use a calculator real quick to find the cube root of 1/28. I'll say 1/28 to the 1/3 power. Now, that doesn't simplify very nicely. And it doesn't seem like we can square root it very nicely either. Okay, but if I want to simplify that, I want to factor out 1/28. So we can express 1/28 as 2 times 64. I think that's far enough. So 4 cubed is 64, so we can rewrite 128 as cube root of 2 times 4 cubed. We can rewrite, and it wants it in containing exponents. I can rewrite this a to the 4th. Cube root of a to the 4th is a to the 4/3 dcy. So just keep in mind that if you, generally speaking, if you have x to the a over b, that's the same as saying b root of x to the a. So for cube root of a to the 4th, I can rewrite that as a to the 4/3. Okay. So for this b, I can rewrite that as b to the 5/3. For the c, I can rewrite that as c to the 6/3. 6/3 simplifies, so I can rewrite that as c squared. Make sense? Okay, now drawing attention to the cube root of 128, which is 2 times 4 to the 3rd, I can factor out that 4 to the 3rd inside the cube root radical, and that makes the exponent go away. I can then rewrite that as -4 times the cube, or rather 2 to the 1/3 power. Okay. Times a to the 4/3 times b to the 5/3 times c squared. Okay. And that should be your final answer. See how I did that? Yeah. Try to work it out for yourself real quick.
So let me look at the last couple of pages. $78, $79.4.
On which page?
4. There be multiple answers for that.
Oh, so which one again?
78 and 79. Page 4, sorry.
Oh. For 78 and 79, find all the values for A that make the statement true. I don't think those are multiple answers, no. I think those are unique values.
I get 79 as an example.
So you want A and you want B. So it's saying A plus 3I must equal. And when I write I, it's like a backwards J, but I mean I. Is equal to 15 minus BI. Why did I write that as a J? Decisions. There's more than one way to look at this, but if you had to make it where A and 3 can only be certain numbers, I would probably rewrite the expression like this. Minus 15 plus I times 3 plus B. You see what I did there? Yeah. Okay, well, that has to equal 0, right? So that's only true if either the sum is equal to 0 or both those coefficients have to equal 0, right? Both those quantities. But the thing is, like, the left quantity has to be a real number and the coefficient of the I has to be. See what I mean? So you can't really combine those like terms. You can't really combine like terms in that case to make it so those are both equal to 0. And keep in mind, A and B have to be real numbers. So you simply have A minus 15 is 0 and 3 plus B is equal to 0. This implies that A is 15 and B is -3. I think that's what it's saying.
0 times. Yeah.
I think that's it. For 78, you can, if you have to get rid of that complex number, so A has to be 4 and B has to be 0. Makes sense.
Yeah.
You could do the process that I just showed you where you subtract 4 on both sides of the A. B has to equal 0 and then A has to equal 4. Makes sense.
Gotcha.
Just let me know when there's any questions. roughly 13 minutes left.
I think I learned what I was missing on freshman.
I do believe there is another review. No, that's for 112B.
Thanks for working on it.
Okay. We can hang out here a few more minutes and have some. I think I will go ahead with this session, because there's nobody on. But that would screw up your projection. Never mind.
Yeah, I just thought of that.
Well, just trying to be efficient
Yeah.
with a real break. I appreciate you guys coming today. I know it's not.
We can. I got one test that's making me a little nervous because I'm not sure what to expect from it. I have the test the next day that I probably need to study a little harder for.